Hi guys! In this video we'll be introducing the mole and calculating amounts of substances. We'll finish off with a summary.
In chemistry, we have a special unit that we use when we're describing the amount of a substance that we have. This unit is called the mole. All the particles involved in chemistry are so small that most chemical reactions involve millions or billions of them. The mole is a really useful measure as it allows us to work out the number of particles that are involved in a chemical reaction, without needing to detect or measure them directly. We define the mole using a standard definition, which is that 1 mole of a substance contains the same number of particles as 12 grams of carbon-12. Where, in exactly the same way as we define the relative atomic mass in terms of 1/12 the mass of one atom of carbon-12, we use carbon-12 in the definition of the mole as one standard for chemists all over the world. The number of particles in 12 grams of carbon-12 is huge, and 1 mole of a substance contains 6.02 times 10 to the 23 particles, which is the number of atoms of carbon you'd find in 12 grams of carbon-12, where carbon-12 is just the most common isotope of carbon. 1 mole of any substance contains the same number of particles, and this number, 6.02 times 10 to the 23, is known as Avogadros constant. We usually write 6.02 times 10 to the 23 in this standard form, because it avoids us having to write all of the zeros. Here you can see Avogadros constant written out in full, showing you that when we're talking about a mole, we're talking about a lot of particles. The important point about the mole is that it's an amount of substance. It's a number. We can see what we mean by thinking about this question, which is how many molecules are there in 2 moles of iodine, and also how many atoms are there. Iodine is a group 7 element, so it's a halogen. And if you've seen our video on the group 7 elements, you'll know that the halogens always exist as diatomic molecules. For example, iodine will naturally be found as an I2 diatomic molecule. Therefore, if we have 2 moles of iodine, what we mean is that we have 2 moles of iodine molecules. We've said that 1 mole of substance contains the same number of particles as 12 grams of carbon-12, and that 12 grams of carbon-12 contains 6.02 times 10 to the 23 carbon atoms. The particles in the definition of the mole can either be atoms or molecules. So for iodine, where it's naturally found as a molecule, 2 moles of iodine will contain the number of molecules in 1 mole, which is 6.02 times 10 to the 23, multiplied by 2 because we're considering 2 moles. This is equal to 1.204 times 10 to the 24 molecules. The second part of this question asks us how many atoms are there. And to do this question, we need to realise that each molecule of iodine corresponds to 2 atoms. And therefore, the total number of atoms within 2 moles of iodine is going to be double the number of molecules. So it's going to be 6.02 times 10 to the 23 for the number of particles in 1 mole, multiplied by 2 because we're thinking about 2 moles, and multiplied by 2 again because each molecule contains 2 atoms. This gives us 2.408 times 10 to the 24, and this time we're talking about atoms. We can use the mole to talk either about molecules or atoms, or anything else. We could even talk about a mole of moles, which would just mean we had 6.02 times 10 to the 23 moles. It doesn't matter what you're referring to, the mole is just about the amount of substance. The really useful feature of the mole comes from its definition, which is that the mass of 1 mole of a substance in grams is equal to either the relative atomic mass of an atom or the relative formula mass of a compound, for whatever substance you're considering. For example, if we have 1 mole of an atom and we could weigh it, we would find that it would weigh the same as the relative atomic mass of that atom in units of grams. Similarly, for a molecule or a compound, 1 mole or 6.02 times 10 to the 23 particles will weigh the same as the relative formula mass in grams. For example, how much does 1 mole of NaCl or sodium chloride weigh? We've just seen that the mass of 1 mole of a substance in grams is going to be equal to the relative atomic mass or relative formula mass. So in this case, the first thing we need to calculate is the relative formula mass of NaCl, which we can do by remembering that the relative formula mass is equal to the sum of the relevant relative atomic masses for the atoms of the element that make up the compound. So in this case, we look in the periodic table to find that the relative atomic mass of sodium is 23 and that the relative atomic mass of chlorine is 35.5, giving us a relative formula mass for sodium chloride of 58.5. Then, to work out how much 1 mole of sodium chloride weighs, we just take this relative formula mass and put it into grams. So we can say that 1 mole of NaCl, or sodium chloride, will weigh 58.5 grams, which is exactly equivalent to saying that 6.02 times 10 to the 23 sodium chloride particles would weigh 58.5 grams. This gives you an idea of how light atoms and molecules are, and that it takes so many just to weigh a few grams. We've just seen that the mass of a mole of a substance in grams is equal to the relative atomic mass or relative formula mass of that substance. This gives us a formula for calculating the number of moles of a substance if we know its mass, which is that the number of moles of a substance is equal to the mass in grams of the substance divided by the relative formula mass or MR value for a compound or molecule, or the relative atomic mass for an element, which is the same as its AR value. Let's look at a quick example of using this formula, which we can use for this question. How many moles are there in 51 grams of ammonia, which is NH3? What this question is saying is how many molecules of ammonia, measured in the units of moles, does it take to weigh 51 grams? To work out the number of moles in 51 grams of ammonia, we can follow a two-step process. The first of which is to calculate the relative formula mass of a compound or molecule, or the relative atomic mass of the element that we're talking about. In this case, we're talking about a molecule, ammonia, so we're going to find out the relative formula mass by summing the relative atomic masses of the component elements. So, for ammonia, we have 1 lot of nitrogen with a relative atomic mass of 14, and 3 lots of hydrogen, which each have a relative atomic mass of 1, giving us a total of 17. Once we have our relative formula mass, we can substitute our values into our equation for moles, which we defined at the start of this slide, telling us that the number of moles is equal to the mass in grams of the substance divided by the relative formula mass. So in this case, our number of moles of ammonia is going to be equal to the mass of the substance in grams, which as you can see from the question is 51, divided by our relative formula mass, which we just calculated was 17. If you work out 51 divided by 17, you'll see that the answer is 3, and therefore that there are 3 moles of ammonia in 51 grams. If we measured out enough ammonia that weighed 51 grams, it would contain 3 moles, and therefore 3 times 6.02 times 10 to the 23 ammonia molecules. We can also use this equation to calculate the mass of a substance if we know the number of moles that we have. For example, what is the mass in grams of 0.1 moles of ethane, which has the chemical formula C2H6? As in the previous question, our first step is to calculate the relative formula mass of the compound or molecule, or the relative atomic mass of the element. In this example, we're talking about ethane, C2H6. So we want to work out the relative formula mass of this molecule, which is going to be 2 times the relative formula mass of carbon, which we can see from the periodic table is 12, plus 6 times the relative formula mass of hydrogen, which is 1. You can see that this comes to 30 as our relative formula mass of ethane. The question is asking us to find the mass in grams of 0.1 moles of ethane, but we started with an equation which gave us the number of moles in terms of the mass and the relative formula mass. We therefore need to rearrange our expression for moles to get an equation for mass in terms of the number of moles and the relative formula mass or relative atomic mass. To start with, let's write down the equation that we already have, which is that moles is equal to mass divided by either the MR or AR value. In order to get an equation for mass, we need to multiply both sides of the equation by the denominator here, which is relative formula mass or relative atomic mass, depending on whether you're looking at molecule, compound or element. If we do this, we get MR or AR multiplied by the number of moles is equal to our mass. And this is in the form that we need for this question. Now we have an equation for mass in terms of number of moles and relative formula mass, we can substitute our values in order to figure out what the mass in grams of 0.1 moles of ethane is. So our mass of ethane is going to be equal to the relative formula mass of ethane, which we found to be 30 in the first part of this question, multiplied by the number of moles, which is given in the question as 0.1. This gives us an answer for the mass of ethane in 0.1 moles of ethane as 3 grams, remembering that the mass in this equation is the mass in grams.
Hey guys, I hope you enjoyed the video. If you are looking for an amazing GCSE chemistry resource, join me today in my series of engaging bite-sized video tutorials. Just click the Stat Revise smiley face and together let's make GCSE chemistry a walk in the park.